We did example 1, but at the bottom is the first picture of the unit circle. Okay, so this picture is the unit circle. All the unit circle is a circle with a center at 0, 0 and a radius of 1. That's why it's called the unit circle, because the radius is 1 unit. Okay? Now, from this circle, this will like redefine trigonometry for us. We look at this, we can explain the cast rule, and today I'm going to introduce you to 3 big ideas for this unit that can all be found just by looking at this circle. So you have the circle, and as they have here, they've labeled one random point, point P. It has the coordinates x comma y, because we don't know what the x is and we don't know what the y is. But if you took that point x comma y and you drew a line straight down, you would make a right angle triangle. Can you see that the height would be y and the base would be x? Okay? Now, with right angle triangles, you've known SOHCAHTOA for a long time. So if I call this angle here theta, then I could say sine of theta is the opposite over the hypotenuse. The opposite length is y. The hypotenuse is 1. This is just simplifies to just y. And cos is the adjacent over the hypotenuse, which is x over 1, which simplifies to just x. And tan is the opposite over the adjacent, so you get y over x. Now, that doesn't seem too crazy, and it isn't too crazy. However, if we pick a random point on the circle, which is x comma y, and sine of theta is y, and cos of theta is x, the first big idea that we have in this unit is that any point on this circle can be labeled, instead of just as x comma y, it can be labeled as cos theta comma sine theta. You don't realize how big of an idea, this is huge. This unit, what ends up happening, it's a scary kind of unit, because I teach you a little thing new, and you're like, oh, this is a little new door that I open. I wonder what I all can do now. You open up this little door, and thousands of questions come pouring out, all in different ways. So it's kind of scary that way. We learn one tiny thing new, and then there's tons of questions that you should now be able to do, but you haven't seen them before. But just having that one new idea allows you to do that. This is the first big idea, that you could label any points on the unit circle as cos theta, sine theta. The interesting thing is this now explains the cast rule. Because if I pick a point in quadrant 2, which coordinate is positive? Which one is negative? The x coordinate's negative in quadrant 2, and the y coordinate's positive. Can you see that that makes cos negative, sine positive? In quadrant 3, both your x and y coordinates would be negative. Both cos and sine are negative in quadrant 3. And in quadrant 4, the x would be positive, the y would be negative. So cos is positive and sine is negative. So the unit circle explains the cast rule. Whereas before with the cast rule, you just sort of we recognized a pattern when we typed it into our calculator, or we just learned this rule, but now it's explained. Second thing that is fascinating about connecting this triangle to the circle. You know that a squared plus b squared equals c squared, right? And so here you would have x squared plus y squared equals 1 squared, and that is actually the equation of a circle. This circle's equation is x squared plus y squared equals 1. If your radius is different, if you had a radius of 2, you could have x squared plus y squared equals 2 squared. That would be the equation for the bigger circle. And if x is cos and y is sine, We also find out from this that cos squared, I'll use theta, cos squared of an angle plus sine squared of an angle is always equal to 1. So you pick any random angle. What's your favorite number? Don't have a favorite number? Okay, pick one now. 10. New favorite number is 10. Okay, so if you did cos of 10, you type that into your calculator, it would give you like 8 decimal places. You then took that number and squared it. It would still give you lots of decimal places. Keep that number in your mind and put it off to the side. You then do sine of 10 degrees, 8 decimal places or more. You square that one. Take both of those answers and add them together. You will get 1. If the angle's the same and you square both of them with cos and sine, it'll always add up to 1, no matter what angle you choose. Okay? If you did cos squared of 37 degrees plus sine squared of 37 degrees, you'd get 1. Mathematically, something new to teach you here. Sine squared this way means the whole thing squared. The reason mathematicians write it this way is they don't like brackets. It takes too long to draw brackets. I'd like to do this faster. Okay? So someone said, well, let's just take the brackets off. And then someone else said, well, if we take the brackets off, how do I know that I want the whole thing squared? Because this looks like I'm just squaring the angle. So they made a decision, okay, if you want the whole thing squared, put the squared in between the sine and the theta. If you just want the theta squared, you can write like this would mean that. Question? Yeah, you can write it with the brackets. Your calculator doesn't allow you to write the little 2 in between, so you have to put brackets around it on your calculator. But you're going to find that we write it so often that it would be annoying to write the brackets. So we'll write it always with the squared in between. In fact, this is the first formula on your formula sheet, but they write it in this direction. It means exactly the same thing. Sine squared theta plus cos squared theta equals 1. Okay? And the third big idea that comes from this little triangle is that if tan of theta is y over x, because that's opposite over adjacent, and we just figured out that y was equal to sine and x was equal to cos, then tan of theta is equal to sine of theta over cos of theta. Just a quick check on our calculator. If I do tan of 10 degrees, new favorite number, 0.176, and then I check what would happen if I did sine of 10 degrees divided by cos of 10 degrees, I get exactly the same number. And it doesn't matter what angle you choose. If you do the same thing with 48 degrees, if your favorite number is 3 or 7 or whatever. Grade 6, my favorite number was 3. At the bottom of the next page, let's summarize the 3 big ideas for this unit. Big idea number 1. Points on the unit circle are cos theta comma sine theta. Big idea number 2, if you do a squared plus b squared equals c squared and use the equation of the circle, you can also write that sine squared plus cos squared of any angle, as long as that angle is the same, is equal to 1. And big idea number 3, that tan of theta is equal to sine of theta over cos of theta. And you know how, like, if someone says, what's the Pythagorean theorem with a triangle, do you have to pull out a formula sheet? No. You feel like a squared plus b squared equals c squared now is like common sense. You look at someone in grade 12, and if they're like, I've never heard of that before, I'm like, where have you been? Doesn't everybody know that? Sort of feels like that's a math common sense thing that you know now. By the end of this semester, you will feel that these three things are common sense. Oh, tan theta, that's sine theta over cos theta. Everybody knows that. Because we're going to use these three big ideas so much. Okay? Right above this, they also have, in this box, the reciprocal trig functions. So sine, cos, and tan, those are your primary trig functions. But we also learn about secant theta, which is 1 over cos of theta. We learn about cosecant of theta, which is 1 over sine of theta, and cotangent of theta, which is 1 over tan theta.
Is that like the when you press second,
No, the second one is the inverse. Like what you're talking about is having sine inverse of theta. These are different. These are 1 over. So 1 over cos, 1 over sine, 1 over tangent. And because you have a big idea that tangent, right, here's our big idea that tan is sine over cos, a reciprocal just flips things. So cotangent, you will also go, oh, so that's cos over sine. Because a reciprocal is when you flip a fraction. And so these are the reciprocal functions. And now you have 6 trig functions you can work with. Up till now, you just use sine, cos, and tan. Now we're going to also include secant, cosecant, and cotangent. Cotangent is going to be the easiest one to remember. How could you remember that? Cotangent goes with tangent. Okay? So once you figured that out, great. The ones that are going to be hard to remember are these ones. Can you see they're similar? They both say secant in them. And you would think that the S should go with sine, but it doesn't. And this one that starts with cos secant. I was like, oh, it's got the word cos in it. So that means, no, it doesn't go with cos. It goes with sine. So those ones are going to be a little bit harder. Right? Maybe you remember that they're the opposite. Maybe that helps you. Okay, so we'll end